What if designing a chip was as simple as writing a prompt? In this video, I'll show you how we go from a natural language description to a simulated VGA design, and finally to a generated ASIC layout in just a few steps. The workflow consists of 3 components. First, the LLM-based chip design chatbot. Second, the VGA playground for real-time hardware simulation. And third, a GitHub repository that triggers the back-end ASIC flow. After inserting your OpenAI API key, the system is ready to translate our ideas into real hardware description code. Let's start simple. I'll ask the AI to generate hardware code that draws a red rectangle on a VGA screen. Instead of writing tens or hundreds of lines of code manually, the AI creates the hardware description for us. Unlike software, this code describes how the physical circuit that is later imprinted into our chip should behave. Now, we copy the code into the simulator and run it. And there it is, a red rectangle on the screen. We just turned a sentence into working digital hardware. But hardware design is always iterative. Let's make it more interesting. I'll ask the AI to make the rectangle slide across the screen by using the input pins of the chip. We update the code, run the simulation again, and immediately see that something is wrong. Instead of sliding smoothly, the rectangle jumps from one side to the other. So we go back to the AI. We describe the problem. The rectangle should move gradually, step by step. The AI updates the hardware code accordingly. And now, it works as intended. Within a few more iterations, I turned the rectangle into a small car and added a street. What started as a static shape has now become an animation. Once we're happy with the design, we copy and upload the final code to GitHub. This automatically starts the chip design process in the background. The system converts our hardware description into a physical chip layout. After the design flow finishes, we can review detailed engineering reports. These reports tell us important things, for example, how large the chip is, whether the signals propagate correctly, and whether all physical design rules are satisfied. In other words, they verify that our design is technically valid. Scrolling down, we can see the 2-dimensional layout of the chip. This is the actual arrangement of tiny digital building blocks on silicon. In other words, the electrical circuit that makes our red car appear on the screen. Finally, we open the 3D viewer. This shows a 3-dimensional model of the final layout. This structure could now be submitted to tiny tape-out for manufacturing in a semiconductor fab, making it part of a real silicon chip. If you'd like to experience this workflow yourself, check the video description for detailed instructions. Start designing your first chip today. You don't need years of hardware experience, just curiosity and your ideas.